The compression of the refrigerant increases the refrigerant's pressure and temperature. After the energy addition step, the high-pressure, high-temperature vapor goes through the heat rejection or heat removal step. In the heat rejection step, the refrigerant rejects the heat it absorbed in the heat absorption step. In the process, the refrigerant changes from a high-temperature vapor to a low-temperature liquid. In the expansion step, the liquid refrigerant is allowed to expand rapidly. This expansion causes the pressure of the liquid to drop. When the liquid's pressure drops, its temperature also drops. After the expansion step, the refrigerant is a low-pressure, low-temperature liquid. The low-pressure, low-temperature refrigerant is ready for the heat absorption step. The refrigerant again absorbs heat from the heat source and changes to a vapor, and the refrigeration cycle continues. A vapor compression refrigeration cycle is basically a four-step process in which heat is absorbed from a heat source and transported to a heat sink where it is rejected from the cycle. A refrigerant is used to transport the heat from the heat source to the heat sink. Let's take a look at the components that are typically used to carry out these steps. In a vapor compression refrigeration cycle, the component in which the refrigerant absorbs heat is an evaporator. In the evaporator, the refrigerant evaporates or boils into a vapor. At the same time, the area around the evaporator is cooled. The evaporator draws heat from its immediate surroundings. This heat is transferred to the refrigerant because the temperature of the refrigerant is lower than the temperature of the evaporator's surroundings. To move the refrigerant through the cycle, energy must be added to it. For many refrigeration cycles, a compressor is used to add energy to the refrigerant so that it can move through the cycle. The compressor receives the refrigerant vapor from the evaporator. Energy is added by squeezing or compressing the vapor into a relatively small space. This increases the vapor's pressure and temperature. The component in which the heat is rejected from the cycle is a condenser. In the condenser, the refrigerant vapor is condensed back into a liquid. As the refrigerant flows through the condenser, it gives off heat. What do you think absorbs this heat? In a condenser, a cooling fluid, which is usually air or water, receives heat from the refrigerant. The refrigerant that condenses in the condenser collects in a receiver. The liquid refrigerant is stored there until it flows on to the expansion step of the cycle. The expansion step in this cycle is carried out by a device called an expansion valve. The expansion valve controls the expansion of the refrigerant and its flow to the evaporator. As the refrigerant passes through the expansion valve, it expands rapidly. This causes the pressure of the refrigerant to drop. The drop in pressure also causes the refrigerant's temperature to drop. So the fluid flowing into the evaporator is a low-pressure, low-temperature liquid. The temperature drop caused by the expansion valve creates a larger temperature difference between the refrigerant and the substance being cooled. This allows more heat to be absorbed. Also, at the lower pressure, the boiling temperature of the refrigerant is lowered. This means that the refrigerant is able to vaporize at a low temperature. In industrial facilities, refrigeration systems are often combined with other systems. Let's look at how a refrigeration system may be used in this way. We'll use a secondary cooling system as an example. Secondary cooling systems are used in many process industries. They remove heat from processes and equipment. A refrigeration system, in turn, removes the heat from the secondary cooling system. Secondary cooling systems typically use coolants such as salt solutions, which are called brine or glycol solutions. Both of these types of solutions have freezing points that are lower than the freezing point of water. This allows the secondary cooling system to operate at lower temperatures than systems that use water as a coolant. The system in our example uses a brine solution. The brine flows through the process equipment where it absorbs heat and cools the equipment. A pump is used to create flow through the brine cooling system. The brine is then pumped to a heat exchanger. The heat exchanger in the brine cooling system is the evaporator in the refrigeration system. In the evaporator, the brine acts as the heat source, and its heat is absorbed by the refrigerant. As the refrigerant flows through the evaporator, it changes to a vapor. The refrigerant then flows on through the rest of the refrigeration system. The cooled brine is directed back to the process equipment, and the cycle continues. In this topic, we saw what a vapor compression refrigeration cycle is and how it works. We looked at the components that carry out the functions of this cycle, and we saw how a vapor compression refrigeration system can be used with a secondary cooling system. Let's stop here and try some practice questions on this material. A typical vapor compression refrigeration cycle has 4 basic steps. They are heat absorption, energy addition, heat rejection, and expansion. Since the steps repeat, the cycle is a closed system, and it is designed to operate continuously. The cycle uses a fluid known as a refrigerant to transport heat through the system. To move the refrigerant through the cycle, energy must be added to it. For many refrigeration cycles, a compressor is used to add energy to the refrigerant so that it can move through the cycle. The compressor receives the refrigerant vapor from the evaporator. Energy is added by squeezing or compressing the vapor into a relatively small space. This increases the vapor's pressure and temperature. The brine flows through the process equipment, where it absorbs heat and cools the equipment. A pump is used to create flow through the brine cooling system. The brine is then pumped to a heat exchanger. The heat exchanger in the brine cooling system is the evaporator in the refrigeration system. In the evaporator, the brine acts as the heat source, and its heat is absorbed by the refrigerant. As the refrigerant flows through the evaporator, it changes to a vapor. The refrigerant then flows on through the rest of the refrigeration system.